from Cycle 35. This is Jeff, and the noisy person on the other end of the microphone is Kevin Williams. And today we're do Python with strings. I think where we stopped last time, like we've been using strings, right? Which are characters that get saved into memory. So essentially, the character gets translated into a bit. The bit gets sent to a piece of memory, and that's how like strings are saved in memory. Well, we've been using strings this whole time, but we haven't really dove deep into strings. So this section is going to teach us some of the more advanced concepts with strings. There's things such as if I want to put a quote in strings, so like my favorite word is um, freedom. I can't put this quote. Like I can cheat and I can put single quotes, but say I'm sending this to a web page and I need it to actually be double quotes. Well, what we have is we have advanced techniques like what's called escape characters. And those escape characters represent this backslash, and it'll allow whenever we print out this word. It's just
an extra quote though.
Favorite word. Yeah, I'll go delete it. 1, 2, 1, 2, 3. Yep. And that's just the IDE for Codecademy. So it prints out freedom in quotes. This backslash is called an escape character. So there's things such as this. There's a bunch of other stuff that there's just a ton of advanced stuff when it comes to strings, and that's what this section deals with. So this lesson here just had us print out our favorite word. One of the most common things that are represented by strings are names. Save your name is a string to my variable. I'm gonna reset this. So.
Wait, I'm gonna say you did that already because they had the name up.
Yeah, man. Yeah, man.
I
sat on my Chromebook last night and went through some of this stuff. So my name, I'm just gonna put team, and then select here. It says select the first letter of the variable. So remember how I said that strings get saved into memory as bits, right?
Yo.
So loud. All right. Remember how I said that strings get saved into memory as bits?
Right.
So that's the reason why we can call indexes on them, such as here. First initial is equal to my name 0. So the reason we can call the first character, in this case T, and store T into the variable first initial. Hold on 1 second. Alright, and we returned. Okay, and man, we gotta get this installed on your computer so you can do some of this recording stuff. I got like a separate hard drive set up for it. Alright, so in this case, first initial, we're storing the T inside of it. And the whole reason that we're allowed to use the index, just like we did with list, is because what it's doing is it's referring to a piece of memory. So this variable is storing team in memory like this. Right? And in memory, it's storing it as indexes. Oh my god. They really need to fix their IDE. Come on, boys. So at the memory level, this is actually what it looks like. It looks like this is how the variable first initial is stored. It's stored as a list of characters that each have an index. And that index, okay, represents a space in memory. So this is part of computer science. So one of the things that a lot of like when you learn to code that they don't teach you is like what is actually happening physically on the computer while you're doing this stuff. Like,
Mhm.
because it doesn't make any sense otherwise. Like, if you don't explain it that, oh yeah, this is being stored into memory as a list of characters, and you can reference those characters via index. Here we'll run my name. But if we run first initial, it just runs T because T is the first index inside of the memory block that's holding um, my name. So all it does is it right here, it creates a mapping from this reference to my name first index. So it's a pointer. It's pointing at. It says, oh, if you need me, go take a look at my name and grab the very first index. And that will be whatever first initial is. So that's why we can change team to beam and immediately run the code and it gets B with no problems. Because it's the way programming works inside of memory is it's pointing to a bunch of references, right? And when we store variables, we create references. Okay, so this is slicing, it looks like. So this is saying indices of the string are shown below in a diagram in blue. So the index 0 will be the letter B. Between indices 1 and 2. So essentially what they're saying is whenever you slice off, and let's reset this. Whenever you slice, you use the slice. If you slice up to the third indice, it will not grab between 3 and 4. It'll grab 0, 1, and 2. But it won't grab the third index. So this is index 0, 1, 2, 3. So when you slice to 3, it'll slice 0. Well, let's test this actually. So let's do fruit is equal to blueberry. Yeah. And then we're going to say new fruit is equal to fruit. And then what we do is we're going to slice up to 3. I think we can do that. Let's run this and see what new fruit gets us. Yeah, it does. It gives us blue. BLU. So what they're saying is these little dotted lines are called indices. And what they represent is the cutoff point on indexes. So when we said that we want to slice everything up until the third indice, what they're saying is grab index 0, 1, and 2. So this comes back to that formula we had, which is n minus 1. Like whenever you're trying to find something, you find like if you need to cut off the fifth letter, the fifth letter would be equal to the index at n minus 1. In this case, it will show you it'll show you 0, 1, 2, 3, 4. Right? Or if we do index 5, we slice at index 5 is equal to n, which is 5 minus 1. So 4 will be the last number or position in the list that you'll get. Okay, let's reset this. Yeah. Is that confusing at all, Kevin? Do you want to add anything there?
Not at all. It's you've explained it pretty straightforward.
All right, so we'll create a new account, and it says that we want to slice the first 5 letters of last name. So what would I put here inside the brackets?
You want to splice the splice. You want to slice the
Yeah.
first 5
That's
letters.
right. Yeah. Splice means to put together. Slice means to slice apart. Yeah.
Right. So you want to do with a colon 4?
Or well, let's see. Colon 4 gives us 4.
Oh, the first 5. So 5, right?
Remember, the first
So you want to slice.
5.
You want to slice everything until
Yeah, because
What?
remember it starts at 0. That's the thing that's going to screw up people is that we count from 0. So the 5th position will give us the 5th value. The 6th, but if we include the 5th position, it'll give us the 6th value. So if we look at last name 5, right? We'll get the next letter here, which is N. So N would have been the next letter. The problem that I think people will have conceptually is that it's hard to picture in your mind that you want to count the letters and you go, that makes sense. VILLA. That's 5 letters. That's the first 5 letters. This is exclusionary. So the 5 is excluding the 5th one. It excludes it. It only includes 0, 1, 2, 3, 4, which happens to be VILLA. Because the 5th one is actually the N. So when we slice up from to a number, so we go from 0, in this case, the no value means start at the beginning and go up until the 5th indice, but don't include the 5th indice. So it'll include all of these, but it'll exclude 5. Versus the other way, which is if you start at 5, okay, it will include 5 and everything until the end. So whenever you see a number on the right side of the colon, when you're doing slices, it means to exclude 5, everything up until 5, right? So from 2 to 5 would be 2, which in this case, 0, 1, 2. So it should start with L, and then it should end at A. So we should get LLA, right? So if we reprint new account, we get LLA. Because it starts at the second index, which if you look, the second index is L, right? Because we start at 0. And it goes up until 5, but does not include 5, which happened to be N. So it included indexes 2, 3, and 4. That's something that's going to be, that I find confusing, like any normal human being would find confusing. But it's something that you have to keep in mind when you're doing slices. So the way to get better at it is with practice. Practice, as Allen Iverson says. Practice. We talking about practice. All right, so we're going to create a variable called temp password. And it says we want to slice out the 3rd through the 6th letters, right, of last name. So, Kevin, what do you think? How do we make that slice? We got to do 3 through 6.
So 3 through 6.
Yep.
So you got to start at 2.
Well, remember, anything to the left of the colon is inclusive. Anything to the right is exclusive. So if we start at 2, okay, let's. Oh, you're right, actually. Yeah, you're right.
Throwing me off, man.
No, you're right, because no, you're right. You're right. Because remember, we start from 0.
Right.
Yep. Through 6.
3rd through the 6th. So
6th letter.
5. That's probably wrong. I think it's 6.
Right. It
Yeah,
is 6. Yeah. So that was good. See, you caught me even. Remember, we start 0, 1, 2. So the first letter, the 3rd letter was actually the second index. So
right.
this number, wherever you want to start, put a hashtag here, will be n minus 1. So if you want to start at 3, you have to subtract 1. And then if you want to end at 6, it'll just be where you want to end, which is n. I guess n would, we could use a different letter. We use n. So n is just a temporary variable that represents any number that you put in. So in this case, when we're looking at the problem, we say third, we would put 3 in here, subtract 1, and that's how we would get 2. And then through the 6th letter, we would put 6 into n and just bring n down. So these are like little formulas that I use to remember how to write these slices. Yeah. So we're good. Next one, concatenating strings. Let's reset. Yeah. Okay, we know how to concatenate. Let's see what the lesson is in here. Copeland's company realizes that their policy of using first 5 letters of employee's last name and user's name isn't ideal. When they have multiple employees with the same last name, write a function. All right, we're writing functions again. Called account generator. That takes 2 inputs, first name, and it looks like last name. And let's extend this so that way it's all on one line. Okay. And concatenates the first 3 letters of each name and returns the new account name. So we want to return the first 3 letters of each. So we want to return first name. We could put this as an expression. First name, we want the first 3 letters. So we're going to slice up till 3. Okay. That's the first 3, right? Yeah, of each, plus the first 3 of the last name. Last name, 3, and then let's go ahead and the way that we unit test functions is that we will save it into a variable. My count is equal to account generator, and then we're going to pass in now what's interesting here is we're passing in actual variables, but we don't have, what we can do is we can pass in we can pass in Kevin, and we should be able to pass in Williams, right? And then we should be able to print my account, and then it should print out Kev Will, right? And so if we look at the requirements, it says the first 3 letters of your first name and the first 3 letters of your last name. So test your function on the first name, last name provided, save it as a variable called new account. So they want it new account, not my account, whatever.
Cool.
What did I do wrong? Okay. The value for new account. Oh my god. You know why? Because they want us to put in the variable first name and the variable last name. Oh. Gotta listen to the requirements, man. Let's expand this so it doesn't look crazy. Let's run it. Syntax error. Where did I screw up at? It says invalid syntax. Where? New account equals account generator first name last. Oh, because I tried to run this as a function. I'm silly. I was calling the function. Cool. More string slicing. All right. Let's reset. All right, so requirements. Copeland's corporate company also wants to update how they generate temporary passwords for new employees. So write a function called password generator. It takes 2 inputs, first name, last name. Okay, let's expand this again. And then concatenate. Ooh, these requirements. All right, man. It's a tough one. So they want us to concatenate the last 3 letters of each of these strings and return them as a string. So we're going to return it. So tell me how we slice off the last 3 pieces of a string. So we know how to do the first 3. First 3 is easy, right? We to do the first 3, we put nothing, then we put a colon, then we put 3. Nice and simple. How do you get the last 3? Do you remember?
No, I was talking the whole time. I was on mute.
Oh, you're mute?
So okay, so to get the what you say, the first three you want
So
to do,
the first
you
three
want to
looks
do
like this, right?
right.
But how
So
do
the
we,
last three will be,
yeah, how do we slice off the last three?
will be colon three, three in the colon.
Nope, that would be
No,
from 3 to the end.
from three to the end.
We want to get
You want to start
the
off the
last three
end.
regardless of the total length. Now there's a way to
Uh,
do it, and we've done it before, but it's sneaky because when we did it with lists, do you remember how we get the very last piece of a list, regardless of how long the list is?
is that it's not appending it though, right?
No, it's
That's
not
something.
appending, but
No, that's
it,
some
it's
what
calling
is it called?
an index, right? But it's calling a negative index. Remember when we did negative indexes?
Right.
Whenever we wanted to remove the last piece of a list, we would target
Copy.
the -1 index. Remember that?
Okay.
So here we can do the same thing.
No copy.
We could target the -3 index.
Okay.
Now the question is, did I put it in the right position? So this is saying from the -3 indexed until the end of the list, return this. And so it says test your function provided. So we'll create a new variable called temp password, and then it's gonna call the function password generator, and we're gonna pass it first name and last name. Oh shit. Okay. And then we're gonna store that and we're gonna print that out. So let's see what we get with temporary password. We get IKO, which is the last 3 indexes, and then we get UKI. So by calling the index with a negative number, it doesn't matter how long the list is. It'll start from the very end of the list, and it will count back 3 spaces and start there. So we can use negative indexing, okay, to target the last X amount of a list. So if we want the last 4 letters, it'd be -4, colon, nothing, which means from the fourth to last character until the end of the list. And that's our slice. Make sense?
Yep. Roger.
Yeah. Okay, so we have what's called negative indices. In the previous exercise, we used length to get a slice of characters at the end of a string. There's a much easier way to do this. We can use negative indices, which is what we just did. So in the previous exercise, I think they wanted us to get the length of the string and then like subtract the position. Oh, fuck that. We're not doing that. The way we just did it is the way to do it. It says use negative indices to find the second to last character in the company motto. Save it to second to last variable. This is easy peasy. Second to last is equal to company motto. And then we get the second to last index, right? And then we run it. Use negative indices to create a slice of the last 4 characters in company motto and save this as final word. So final word is equal to, and we literally just did this right in our other exercise. So we're slicing off that piece, and then let's print out the final word so we can see it. And it's life. So this is the same thing we literally just did. So I'm not gonna go into it too much. Okay. So strings are immutable. Kevin, what does immutable mean?
The states cannot be changed.
There you go. So this property is generally known as mutability. Data types that are mutable can be changed, and data types like strings that are immutable cannot be changed. So the most recent hire at Copeland's corporate company is a fellow named Rob Daly. Unfortunately, Human Resources seems to have made a bit of a typo and sent over the wrong first name. Try changing the first character and first name by running this. So we're going to run the code that they gave us. And this is saying, okay, grab the first name variable and change the first memory index to R instead of B. It gives us an error. So programming languages protect the memory, okay, on certain data types for security. Because if you're a hacker, you could go in and you can take these little pieces of memory and you can change the bits around, and then the string instead of Bob Daly could come out Rob Daly. So you could program over what other people programmed to hack somebody's software, so to speak. So a lot of languages have these things called immutability, which protect the language from not only unnatural behavior and unexpected behavior, but also from people doing bad things like coming in and changing the values of your string in memory. So they're going to teach us how we can sort of programmatically go around it in a safe way. So here it says, okay, there's no problem, we can fix this. Concatenate the string R with a slice of the first name that includes everything but the first character and save it to a new string. So what they're telling us here, okay, is that in order to create the correct value, we have to create a new variable to store this information in. And what they want us to do is take this R and they want it to add it to the first name, okay, the first name with the first index sliced off. So from the first, after the first index forward, essentially. And then if we want, we can print fixed first name, and there is an error here because we should just comment out this piece. And we created Rob. We created Rob inside of a new variable. The first name variable never changes its value. Okay? All we did was we said concatenate R, slice off the very first letter of first name, which is then would be OB. So now you can kind of see how valuable slicing is.
Okay.
Right? Escape characters. I think we went over this. So they're saying whenever you want to put characters that are used in Python for other things, we have to use these special characters, which right above your enter key, right before the character you want to define, you have to put the backslash or forward slash. I forget they call it forward slash. They call it forward slash. The forward slash, which is the key right above your enter key, before the special character. So for example, we use equals, right? But if you wanted to put equals inside of here, which I think is a bad example because I think equals becomes a string. So I'm trying to think of something else. I don't know. We could put equals. It would have to be an escape character equals, right? But in this case, we did quotes. So let's just run this.
So it's going to include the quotes.
Yeah. So if we printed this out.
Print, they call me quote unquote crazy. Right.
Yeah. So if we print, they call me crazy. This won't print, right? Because if you try to run this, it'll say this makes no sense. So we have to put the escape character there, and then we run it, and then it says they call me crazy in quotes. So remember, the key that's above your return key is called an escape character. It escapes out of the code and allows you to put in characters that are normally represented a different way in the language.
Print password.
Huh?
They try and print password. See, it's gonna be the same thing.
Yep. And actually, we should probably, have a quote. Yeah. And then if we got rid of the escape character, reran it, it would have an error.
Yeah, right.
Now, what's interesting is if we put one escape character there, They call me crazy. Does that run? No. You still, both quotes have to have the escape character.
Yep.
All right, good to know. Moving
Because I
on.
guess the system is expecting it to be a string then, because it's not. You're not the
Right.
escape character.
It says if you don't have the escape character, then what it sees is it sees this is a string, this is a command or a variable, right? And then this is a string. Whereas if you put the escape characters, it reads the whole thing as a string. And that's how I was talking about, like, there's more advanced things with strings than what we've been working through. That's one example. Because strings are lists, this means we can iterate through a string using for or while loops. This opens up a whole range of possibilities and ways we can manipulate and analyze strings. So here's an example. This will print each letter in a word. Cool. It says let's try it. Let's replicate a function we are already familiar with, length. Write a new function called getLength. So getLength, and it takes a string, I'm just going to write string, as a parameter, and returns the number of characters. So it will return the number of characters in that string. Do this by iterating through the string. Don't cheat. Use length. Oh, I was so gonna cheat. All right. So what we can do is we can say count is equal to 0, and then we can say for word or letter in string. For each letter in string, count plus 1, and then we can print out count when it's out of the, right? And then what we can do is we can create a variable called by count is equal to get length. Give me a string, any string.
Count. No, you can't use count. Red. The
Right.
red.
And then print my count. Let's run this. None. Okay, expected get length to return 4 for the string test. Instead return none. Because I think what happens is you have to add it like that. Yep. So 3. After print, is this my list? No. What is going wrong? Expected to return 4 for the string test. Instead it returned none. So, oh, you know what? Maybe we have to do a return statement. Return count. Inconsistent use of tabs.
Return 4.
Hold on. Should be correct. Yeah, that worked. So return count. Okay, so instead of printing the statement, I was supposed to return the statement. So so there was a unit test underneath the IDE that we don't see that they used to test. Here we tested our letter red and it came back with 3. So it worked. And what we did is we did the standard create an empty variable, set it to 0, loop through each thing in the in whatever our we put in, loop through each index for everything we put in, and then just count up. Count. Right? I think we could have done this. I think we could have done plus plus. Let's see. No, we cannot do plus plus. Has to be plus equal. Cool. And then return count once we're done with this loop. So this loop will loop through 3 times and then give us back 3. Easy peasy. Alright. So we got 2 more lessons.
Oh, wow.
We're almost done. Take a look at the following code. Favorite fruit, blueberry, counter 0. We just did this. If the character is equal to B, then counter equals +1, print count. This code will count the number of B's in blueberry. Let's take a moment to break down what's happening. We should know what's happening by now. So let's write a function called letter check. It takes 2 inputs, word and letter. Word and letter. Okay. And it should return true if the word contains letter and false if it does not. So we would say if word
assign The double equal?
No, we would.
No?
So we would. So what we would do is we
Okay,
would
4.
say,
Yeah.
yeah, or we could say while. I mean, why? I mean, you could do while here as well, but we'll do
Well,
4.
it says if. It said return true if the word contains letter.
Yeah. So then for each letter, uh, for each item in Word, right? If item is equal to is it 3 equals or 2 equals?
It's
2
2.
equals. 2 is equal to letter, right? So letter is the letter we're looking for. Return true. Okay. And then what we could do is we could just break right away instead of having to iterate through the rest of it. And then this is what's so crazy. It's like I wish I had some way where I could see the position of the cursor down here. Like I think it's here. I'll also return false. So if it ever finds true, it'll return true. Otherwise, it'll return false. So let's run it. So expected letter check strawberry to A to return true. So let's test
What?
let's use their unit test here.
Where did it say strawberry at?
It's a unit test that exists underneath. So let's call fruit is equal to letter check, and the word is going to be strawberry, right? And we're going to look for the letter A, right? So those are 2 inputs, right? So the first thing we can do is we can, before we return true, we can check to see if true was ever created. We can look for, we can just print item and see what prints out. See if anything prints out. Nothing prints out. So nothing ever went to true. So if item is equal to letter, so here's what we'll do. We'll print letter, and then inside of here we're gonna print item. So we're gonna look at letters, and then we're gonna look at items and see what happens. So A comes in, S hits. If item is equal to letter, return true and break. Else return true false. Maybe that break was screwing it up. No. So we're looking for A, and it only ran through once. Item in Word. For each item in Word, print item. So it printed S for strawberry, and then it evaluated. It said if, ooh, you know what? I think we don't need an else statement. Let's just try. Let's run this. Yeah. So the else statement. That's interesting. It only printed out STRA out of strawberry, which I misspelled, by the way. So let's get rid of all of this, and let's just print this. So there it prints all of strawberry, right? And instead of item, because I think that's convoluted, we know that everything that is coming into, so now we know that, what's going on here? Oh, because I changed this. We know that everything that's coming into here is correct now. We know that we're getting all of our letters. And now what we need to do, we need to check if I is equal. If I is equal to letter, print success. So, okay. We're making progress, Kevin. So, here we're going to return true. Okay. So returning breaks the loop. So what happens is we should continue, right? Else continue maybe? Let's see. Let's just try running that. So it does, we do get up to the A, it compares the A, and then it returns true. But we did something wrong with this else statement. What did we do wrong?
Why do you have continue right there?
So it means to skip if it's false. Skip over it. We could return false, but if we return false, the first thing that gets evaluated returns false. So we might want to say elif return false. Is elif correct? Elif. I have to put a condition. I does not equal letter. Let's run that. No, that didn't work either. All right, man. So this is basic coding. What did I do wrong here? I need you, Kevin, because I'm totally blanking on this. So it might be a while loop. Let's see. Make sure to test your function. Try running pi. Letter check. Start. Blah blah blah. So
you want to return true if the word contains the letter. If the word contains the letter.
Right. So here it'll return true. Right. It'll 100% because if you print true, and you rerun this, it goes down, it finds it, it prints true. Right. So that's the first part of the requirement.
Because it stopped at A. Well, why did it start? Okay, so it's counting the letter first, right? So print letter, then you have.
Yeah, I'm printing a letter just to see the letter. So for every I in Word that gets put in, I is equal to letter. Then we're gonna print true.
Then it stopped at the second A, or the first A in strawberry, and said true.
Right, because the requirement says this function should return true if the word contains a letter. So if it contains this, it should be true. Period.
Right.
If it doesn't contain it, then it should be false.
So you already tried else?
I have tried else, but what happens is the first letter will hit this. So right, so if I just print false, right, and I rerun this, it'll evaluate it, say it's false, evaluate it, say it's false. We can't return false. It has to go through every. Oh, you know what?
What about break?
Nah, bro. Okay, follow me for a second. We just return false if the if statement never runs true. Now, that's not right though. So if I is equal to equal letter, return false. So I feel like return true, else return false. I think so. Just seems like it would be right? Because so it loops. Here's the loop. It has to be. So the return statement has to be outside of the loop. Period. Right? So then this is one of the problems with not having like Codecademy or if we were to put this into our IDE, our Visual Studio Code, right? Okay, we could see how everything lines up. The for statement, this return has to be outside of the loop. So the for statement ends at this return statement, and this return has to be lined up with this for statement, which I think it is now. So let's go back and let's run this. Yeah. Okay, wow. That's just a formatting error, dude. Okay, cool. We learned something. So, all right, I'm gonna walk you through this. You ready? Or do you get it? You want to walk me through it?
Yeah, let's walk through it.
Okay, so let's get rid of our little test-driven snippets here. Okay, get rid of I. So I was just doing that to expose what we were seeing.
Mm-hmm.
Okay, so what's happening here is this is the loop. Okay, the loop only needs to check if something's true. It doesn't give a shit if it's false. So we don't need to return false. All we need to do is go through the loop until the loop doesn't return true. If the loop returns true, the code stops.
Mm-hmm.
Okay? The code returns out of the for loop and it says true. If the code returns out of the loop without true, it'll move on to the next piece of code and return false. So what we're going to do is we're going to test this. We're going to test this by saying print fruit. And we're going to run it. And it comes back true. Right? Now, if we change this letter to something that's not in there, it should come back false. It comes back false. So what's happening is when we hit A, it goes through, it loops through each character, it finds A, and then it returns true and it stops the code, period. Once we return, the code stops. It never gets to false. But if we did Z, it loops through the entire word and never finds Z in that word. So it exits the loop and moves on to the next piece of code and executes it. And then says return false is the next piece of code that happens. So if this loop never returns true, it'll skip it and move on to the next piece of code, which just says return false by default. You got it?
Yeah.
Don't lie to me. Do you got it, or is it confusing?
No, I got it.
Cool. All right. Because that was confusing me for a second until I realized, okay, we need to be outside the loop to return false.
I was confused why it didn't work when you use else. Well, you just explained it because when it's true.
So I'll show you why. Because anytime we return, it breaks the code, right? Remember? Right. So it'll only ever hit S. Because S comes in, it says, is S equal to A? If it is, then it's true. Break out of the code and return true. If it's not, break out of the code and return false. It breaks out of the code. It never executes this loop ever again.
Okay.
So that's what that's what I was confused about. I was like, wait a minute, we got to take it outside of the loop, and we have to return false only if this check never happens. If we never see true, then we have to return false. So we're breaking the code. Wow. Okay. Whew. I'm telling you, man. It's tough, dude. It's not easy. Some of it's easy, some of it's not. There's an even easier way to iterate through entire string to determine if a character is in the string. We can do this by a type of check more efficiently using in. In checks if one part of the string is in another string. Oh, that's easy. I wish you would have had that. Here, letter in words is a Boolean expression that returns true. What? What? You see this? Okay, well, here we're going to say value is equal to, and then we're going to print value. It should print true. Yeah. And then we'll change this to Z.
Wait, what? So what's value?
Value is a random variable I created. So what it's doing is it's checking for this character inside of the string, and then I'm printing out that variable.
So you're testing the in keyword.
Yes. Exactly. So that's pretty cool. So that's like a shorthand. So, okay. So write a function. So you want to do this one?
Let me try to read ahead. Okay, so you want to define your function contains. You got two parameters. You got big string, comma little string.
Yeah, that's right.
And returns true if. Okay, so return true. No, you want to, if. if big string in little string, and then return true inside of the loop.
What loop?
What the function? Sorry.
All right, let's read the requirements. That takes two arguments, big string, little string, and returns true if big string contains little string. Ah, we had this backwards. So big
Oh,
string is
okay.
could hold
Yeah,
little string.
yeah. If returns true if big string contains little string. Right, right. Okay.
Write a function. Okay, let's run it. See if it works. No, it was wrong.
What?
Well, we didn't test it, so let's test it, right? So, oh, why does it do that? Test equals. Oh, so that's so annoying. Come on, Code Academy, I believe in you. Test is equal
It's
to
like merging.
contains. Huh?
No, it's like it autocorrects. It's like writing an essay in Microsoft Word.
Yeah. It what it does is it say, oh, you're trying to write underneath this function, so I'm gonna auto tab complete, but I'm not gonna show you the position of the cursor. Okay, so let's print test. That was wrong. But it came back true. It takes two arguments. Did I write something wrong? Big string and little string. And returns true if little string in big string return true. That's absolutely right. Expected contains watermelon and berry to return false. Oh, you know why? Because I never put a return false statement. So this is part of test driven development. Okay, so it's like this is test one, print test one, and then print test two should be something that makes it fail. And honestly, you should write your failures first. So like we should expect this to be false.
You say that's TDD.
Test driven, yeah. Like you would write your test to create an error first. And here we get true false, right? This is also known as green red testing. Um, okay, so I'll do this one. Write a function called common letters. I should maybe instantiate it as a function. Letters, it takes two arguments, string one in string two, and then returns a list with all the letters they have in common. What? Okay. So I'm gonna create my list, and it's gonna be empty, and I'm gonna say, holy smokes, can if string one in string two, this I have to do a loop with this, right? The letters should be return list should be unique. For example, so did I miss something up here? Let's see. In fact, this method is more powerful. A in blueberry. Let's see. Blue and blueberry is true. Almost feel like we have to go through like each letter. God, this seems like a hard one, right? Am I wrong on this? Write a function called common letters that takes two arguments, string one and string two. Then return a list with all of the letters they have in common. So let's write this test down here. You know, assuming it'll let me. Jesus Christ. And this will be test 3 will be common letters. And we're going to pass watermelon and melon. Okay. And then for So part of me when looking at this wants to say, okay, find the length of find the length of string 1, right? And then find the length of string 2. And then whichever one is bigger, look for the other one inside of the other one. So I'm just going to go with my gut here. And I'm going to say L string 1, or we should say if string 1 so if the length of string 1 is greater than the length of string 2, okay, so if the length of string 1 is greater than the length, meaning the word string 1 is greater than the word of string 2, then string 2 in string 1 will return true or false. Do I have to loop over? I don't know how to do this. Let's see. Append will be useful. Adding shared letters. Also, you make sure you test your functions. Use when adding the shared letters to the list you will eventually return. I already know that. Like, come on. Right? Right? So here, let me separate this. This will be my list will be equal to an empty list, right? And then it says, I don't know like why it's in this. Because in my head, I want to find out which one's bigger, see if string 2 is in string 1. No, that's wrong. Or maybe you should loop over? I don't know. What do you think, Evan? Before I go like super deep into...
Scroll up on the instructions a bit.
Yeah, so this is definitely a loop though, right? So it has to be a loop. It has to. So it has to be. So for each letter in string 1, right? Okay. No, you know what? I was right. The first thing we have to do, the first thing we should do, is find out which one's bigger. Okay? Then, okay, if the length of string 1 is greater than the length of string 2, let's just write out this one example, right? Go into, so we're saying that string 1 is the larger word. Then what we should do is we should look at every single letter in string 2 for letter in string 2, right? If letter so if letter is in string 1, then we take the letter and we append it to my list. So what we're doing is we're saying, okay, so if string 1's larger than string 2, look at string 2. Give me every single letter inside of string 2. If the letter from the string 2, for each letter in string 2, is in string 1, then append that letter to my list. Here's the problem, though. It has to check that list first. It has to say, so if letter is in string 1, then append this list here, my list, okay? But it should also check that list. It should say, if letter is in my list, or not in. How do I say not in? So I can say if letter is in my list.
You use false.
Well, I don't want to return. I want. How do I say not in?
Oh, you use
If
the
letter.
assignment, the equal and exclamation, right? What is that called? Not equal?
I'm gonna use continue to skip it.
Okay.
And then I'm gonna say else append my list letter. Yeah. Okay. So luckily, okay. And then we'll eventually oh, so dumb. So it's right here. Well, eventually what we'll do is we'll return my list. The indents could be all fucked up. Let's see. Return my list. Syntax error. Common letters. What? Watermelon. Invalid syntax. What are they talking about?
Go to 27. Scroll down.
Was it line 27 it said?
Yeah.
Oh, God. It's because I put that there. Alright. Okay. So some other errors. Test 3. Again. Attribute error. String object has no attribute to append. So append my list. So, oh, it's my list. Oh, it's the other way around. It's a my list append letter. We're putting our letters in the list. Let's run this. Okay, cool. So we get a return statement back. Or we don't get any errors in the function itself. So what we can do is we can print test 3, and then we'll comment out test 1 and test 2, and we'll rerun this. Okay.
Malone.
Okay, so that works. However, okay. So remember how I said we did it one way? We have to look at this and do it the other way, right? So this is a huge if statement, right? So we have to write an else, right? Oh,
Yeah.
God.
You lost me at continue. I keep forgetting about continue.
So continue means to skip. It's a way to cheat.
Right. Yeah.
It says it's like a negative. So if this is true, then just skip over it. If the letter's already in my list, then just continue. Otherwise, take that letter and add it to my list.
Without the continue, it'll once it's true, it'll just stop, right? And then
if I don't have continue, yeah, it'll skip over the else statement and move on to the next letter.
Okay.
So I want it to skip over. Okay. Holy smokes, dude. Okay, so the other option is that string 2 is larger than string 1. Which means we have to do the exact same thing, and this is where we need to refactor our code. Oh my god, it doesn't even copy correctly. Come on. So let's start here. So let's copy all of this and then paste it. Okay. So this is the else statement.
Mm-hmm.
And it's each letter in string 1 needs to be switched with string 2. And then run. Okay, it passes. Woo! Oh man. Although this returns none. Test 3 should be common letters, watermelon. Why did it print none? Return my list is outside of the. That's why. It was under the else statement. Oh my god, this is so wrong, dude. We have to refactor this. This looks terrible, right?
Yeah. You gotta get a shorter way to do that, though, right?
Huh? So there is a shorter way to do it. The question is, we have to figure out. Like we should not be satisfied with this, even though yes, we completed the requirements. But look, we're repeating everything we did,
Mm-hmm.
which is bad. It's bad practice. So let's talk this out. If so, melon does it matter if we're looking at melon or watermelon? I don't think it does, right? Because if we're trying to find each letter that's part of watermelon that's in melon, it doesn't matter. So I don't think we need this if statement here. And I don't think we need the else statement. Okay? So I'm just going to compare the two strings right at each other and see what happens. Indentation error, of course. Because everything needs to be brought back to backspaces. 1, 2, 1, 2. And run. Okay, and that worked. Okay, so that looks a little bit better. Okay, so this is where my logic failed me. My logic in my head said, okay, I want to find whoever's the largest string, and I want to find the smallest string within the largest string, which may have calculated faster. I don't know. But in reality, we just need to compare. We need to look at watermelon and melon, and then we need to figure out which letters that they have in common. So it didn't matter which one was larger. So in this one, it said for every single letter that's in string 2, which is melon, look at string 1, and first look and see if this list has any letters in it. If it doesn't, take my list and this right here, my list, and add the letter we're looking at only if that letter exists into string 1. So look at string 2, grab me M. If M is in watermelon, okay, first look at our list and see if it's already there. If it's not there, then append it. So what this continue does is it helps to ignore this else statement. So by saying continue, it never even looks at else. It just skips this block and goes back to the beginning of the loop.
Okay.
So it's a way to skip this else statement because this if statement's just checking our list. And if there's no letter, if the letter doesn't exist in the list but it's part of both words, then it will and it's not part of that list, it'll skip over this and it'll hit our else statement. Our else statement will then trigger and take that letter, in this case M, and append it to my list. And so list, that's why list has M first. And so we can do this with any two words. So holy smokes, dude, that was a difficult one. Holy cow. So here's the final lesson for tonight. And this is Copeland's corporate company has finalized what they want their username and temporary password creation to be. Have enlisted your help once again to build a function to generate them. In this exercise, you will create two functions. So we know we need two functions, which is username generator, and the second one's going to be password generator. Okay, so the username generator is going to take first name and last name. Oh, expand. First name and last name, and then return a username. Alright, so the username should be a slice of the first 3 letters of their first names and first 4 letters of their last name. Okay, so let's write that requirement. So how do I get the first 4 slices of the first name?
Sorry, I was on mute.
All
right. Yeah, you get so you concatenated first name and last name. Yeah. Why did you?
Oh, so I'm just typing here. You drive. So the requirements so far are to return a username, and the username. These are the requirements here. The username should do that.
All right. So you want to slice? So you do the colon 3. You get the first 3
on their
right.
first name, right? So yeah. So
No,
first name.
well, 0, 1, 2.
First name. You said slice the first. We need the first three letters, right? Yeah.
Yeah.
Okay.
And then should be the slice the first 2 letters of their first name and the first 4 letters of their last name. So you got to concatenate first name concatenated with last name colon 4, slice 4.
Colon 4. Colon 4.
Colon 4, yeah.
First 4 letters of last name. If.
Yeah. Okay.
Their
Then
first name is less than 3 letters. So actually, we can say here we go.
Yeah, I was just about to say call that username. Yeah.
All right, let's look at our conditional statement.
If first name less than 3 letters, so if the first name is less than 3 letters, or their last name is less than 4 letters, it should use their entire name.
Yep.
Oh, smooth.
So we know that's an if statement, and so the first one says, if their first name is less than 3 letters. So we know if the first name.
Would you need a variable called entire name then? Full name, I guess?
Why?
Because it said if.
Oh, to use their full name?
Yeah, because it says
Yeah,
it should return.
you would. I mean, you could. But what would you put in there? What would you put in full name?
Okay, so
just like concatenate first.
Yeah, concatenate the first and last name.
Okay. Okay. So if their first name is less than 3 letters, so if the length of the first name is less than 3, right?
Right.
Or
could you use the double pipe for or?
I don't know. Or the length of their last
name. Yeah, because it's either or.
Last name is less than 4. Use their entire names. Return
full name.
Full name. Okay. All right, let's run it. See what happens. What do we
do?
Because
yeah.
Invalid syntax.
The pipe.
Oh, it's just one pipe? I know in JavaScript it's 2 pipes.
Is it one pipe? No. It should be 2 pipes.
I thought it was 2. It says it's invalid. Is it literally just like actually or? Ooh. Can we just try or? Let's try or. Unexpected EOF while parsing on line 10. There's no line 10. What are they talking about? Oh. Oh, okay. Because I didn't, okay. That passed? It passed! Alright. Alright.
So it's really just or? In Python, it's just or?
Dude. Alright. So let's do test 1 is equal to username. We need 2, so username generator. And let's use the example they gave us in here, which is Abe Simpson should generate the username Abe Simpson. Let's pass in Abe. No, what's a 2-letter name? Like Chinese people have 2 letters, like Hugh or something, right? Like Chan, and then
Chinese
last name. Yeah, people from China, they have like last names like Hugh, and or Koreans have like Sung, S-U-N. We'll just do Chan-Hu.
And I'm confused. I don't get it.
Okay, so we have to test. What we do is we have to test our our use case here, right? So if the first name is less
Oh,
than
okay.
3, which it's
Right.
just
Okay.
not,
Okay.
or the length of the last name is less than 4, we need to print out test1.
Right.
It prints out the full
Looking
name.
for, looking for a short name.
Right. So that's our first test case. And our second test case would be a normal name. So we'll put in Dwan again, right? And then we'll print test2, and then we'll run it, and it puts out Dwan Gant, right? So that's how we're building our usernames. So these
Right.
are, again, for those of you who are watching who somehow made it this far and aren't bored out of your minds, these are our unit tests. And then what you should do is you should write here should return Chan Hugh, and then under here we should write should return Dwa Gant. So that way the tests are there. Essentially, you would this would all be commented out and even cut out. You would cut it out and you would put it in like a separate sheet somewhere. And then you can say, hey, these were the test cases, and your function works, and this is how we know it works. But in this case, we'll just do that. Cool. So moving on. Next, great work. Now for the temporary password, they want a function to take the user input name and shift all the letters by 1 to the right, so that the last letter of the username ends up as the first letter, so and so forth. For example, if the username is Abe Simp, then the temporary password should be Abe Sim with the letter P at the end of it. No problem. Start by defining a function called password generator. So, and it takes username. Now, obviously, that username it's going to take is probably going to be our test1 or our test2, because those are our usernames. All right, so let's look at the requirements. So what we want to do is we want to take username. We're going to create a new password. It's going to be equal to. We want to take the input username and shift all the letters by 1 to the right. So if we shift everything by 1 to the right, we want to get the very last part of username. So the very last part of username, the very last character of username. Okay?
Mm.
And then what we want to do is we want to add it
to the beginning of the list?
To username, but we want to slice off everything from the beginning to the very end.
Okay.
But we don't want the very end. And then what we can do here is we can return a new password. And then we want to print test3. We want to create a third test. Test3 is equal to can it just be test1? Yeah. So password generator, and we're gonna put in test1. So test1 here is Chan Hugh gets returned. So that's automatically going to be put into our password generator function. And then we get to print out test3 and run it. Hey, look at that. It worked. So you know what's going on here? Do I need to explain this?
Yeah. Okay. I forgot about the negative. I would have thought of that.
Yeah. So if you think about it, they want us to slide everything over 1 by right, which really just means they want us to take the last letter, which is what we did here. For those of you who are watching, the very last letter of username, and then we're going to take that by itself, and then we want to add it back to the username without that letter that we just took out. So that's why Chan H, right? The U, we sliced off the U, we created a new variable, we stuck the U inside of it, and then we sliced off everything except the last letter of the previous username, and then stuck it back into our new password variable. So
That's
fancy. Little clever trickery going on there. All right. So inside password generator, oh my god. Create a for loop that iterates through the indices username going from 0 to length username. To shift the letters right at each letter of the loop should the previous... No, dude. The way we did it was better. You see this? Create a loop that iterates through the indices username going from 0 to the end of the username. To shift the letters right at each letter of the for loop should add the previous letter to the string password. Yeah. So the way they wanted us to do this was they wanted us to say for letter in username, okay, and then we would create something called I don't know, user equal to... No, that's wrong. For each letter, create a for loop that iterates through the indices of the username going from 0 to for letter in username. Oh, you know what? Jesus Christ. It would have been range or something, right? It would have been for each index that's in username. And it would have been the range based on the length. Like, I'm not going to do this. Like, this is insane. Why would somebody do this? No, the way we did it was more clever, in my opinion.
Yeah.
It was 3 lines of code. This would have been like 5 lines of code. Screw them. Is there a way where this wouldn't work? I don't think this would ever not work based on their requirements. So, whatever. Okay. All right, that's it. Thank you for doing strings. And next time, if we take a look, we're going to be going over string methods. Oh, man. String methods. How big is this bad boy? Formatting, splitting, more splitting, joining, stripping, replacing, find format. So I'm going to... Yeah, dude. This is all the methods that are built into Python. So I'll go ahead and I'll probably do these tomorrow night. Because I got training all day tomorrow. So for Cycle 35, I'm Jeff, and that is K-Will.
Kevin.
Kevin.
K-Will.
And we'll see you next time.